Alright, in this lesson we're going to learn how to divide polynomials. We're going to use two different methods that you need to be really familiar with. We're going to use synthetic and long division. So by the end of this lesson you should be able to take this problem and divide it out. Alright, so we're going to go back to 4th grade and see if you can do long division and take 5,815 and divide it by 8. So if you remember back, we're looking for how many times can 8 go into 5 evenly. Well, 8 can't go into 5 evenly because it's bigger, so we have to include the next number as well. So then we say, how many times can 8 go into 58? So 8 goes into 58 7 times, and then we do 7 times 8, and so 7 times 8 is 56. And that gave me a positive 56. So in order to keep going, I do the opposite, and so I end up subtracting. So 58 minus 56 is 2, and then I bring down the 1, and then I repeat that process. So how do I get 8 to go into 21? Well, 8 times 2 is the closest I can get, and then I distribute. 2 times 8 is 16, and then I do the opposite. And so it was positive, it becomes negative. I subtract, and I get 5. And then I bring down my next number, and I say, how many times can 8 go into 55? And the answer is 6. And so I do 6 times 8, which is 48. And then I'm going to do the opposite, so I subtract, and I'm left with 7. And 8 cannot go into 7 anymore, so you used to put remainder of 7, but what we're going to actually do is we're going to say plus 7/8, because we're taking 7 and dividing it by 8. So our remainder goes in the numerator, and what we're dividing into it goes in the denominator. So the correct answer is 726 plus 7/8. So the reason we walk through that process is because we're going to use this exact same thinking to divide polynomials. Alright, so we're going to go through that, and we're going to use long division to divide this polynomial right here. So the first thing we're going to do is we're going to make our division box, and then what we have to do is we start with the largest degree, so v to the third, and we can't skip any degrees, so I have to have a placeholder. So if there aren't any v to the seconds, then I would need to put 0 v to the seconds because I can't skip places. But this one thankfully goes third, second, first to the 0 power, and I'm dividing it by v plus 7. Alright, so how I'm going to start this out is now I have a binomial, and I'm trying to get that binomial to go into this monomial. Well, just like before, I can't have 8 go into 5, so I have to go over one more. So I'm actually going to look at v plus 7 going into v to the third plus 9v to the second. Alright, so to do that, I'm always going to look at this value right here, and I'm going to look at the first number on the inside, and I'm going to think, what could I multiply v by to make it look like v to the third? So what times v would give me v to the third? Well, that's v to the second. And I line it up above here because I'm doing a binomial into this binomial. So I put it over here, just like in the previous one, we put that 7 above the 8 in 58, not the 5. All right, so then when you think back to what we did once we found what went into it, well, then we multiplied. Well, in this case, I'm multiplying v to the second times this binomial, so I need to remember to distribute. So v to the second times v is v to the third, and v to the second times 7 is 7v to the second. So then once we did that, we subtracted, or we did the opposite. So if it's positive, it becomes negative, and if it's negative, it becomes positive, and then I combine my like terms. So v to the third minus v to the third cancels, which is what we want, and that's why we thought through, how do I make v look like v to the third, because I want it to cancel. And so then I do 9v squared, and it became minus 7v to the second, and so that gives me 2v to the second. And then if you remember, we bring down our next term, so plus 7v, and we start all over. how can I make v look like 2v squared? So I'm going to multiply it by 2v, because 2 times 1 is 2, and v times v is v squared. So now I'm going to distribute. So I'm going to do 2v times v and 2v times 7. So 2v times v is 2v squared, which is what we wanted, and 2v times 7 is a positive 14v. All right, now I'm going to do the opposites, or I'm going to subtract. So I'm going to turn them both negative because they're both positive, and 2v squared minus 2v squared cancels, which is what I wanted, and 7v minus 14v is negative 7v. Bring down my next term, so negative 50, and I'm going to start all over. All right, how do I make v look like negative 7v? Well, I'm going to multiply it by negative 7, and then I'm going to distribute. So negative 7 times v and negative 7 times 7. So negative 7 times v is negative 7v, and negative 7 times 7 is negative 49. All right, and then I'm going to do the opposite. I'm going to subtract, essentially. And so these will cancel, and then negative 50 plus 49 is negative 1. And I just realized I copied this problem wrong, and it's actually negative 56, and so negative 56 plus 49 is negative 7. I'm so sorry for that. And so my remainder is negative 7 because I cannot make v look like negative 7, and it's also a monomial. So my remainder is just minus 7 over v plus 7 because I can't divide it any further, and that is my answer. Alright, so I know that process is a lot, so what I'd like you to do is go ahead and write down any questions. Where did I get numbers that you don't understand? What was I doing that is confusing? Or write down things that you do understand. So what steps did I go through? We're going to do multiple examples, so there'll be plenty of opportunity for you to understand. Alright, I'm also going to show you synthetic division. And so I'm going to show you this exact same process, but I'm going to show you the synthetic division version. The important thing is that you need to know both processes. You can choose which one you want if it's an open question, but you do need to know both for future math classes. So the first thing we're going to start out with is kind of an upside down division. And we put the coefficients of the first whatever's being divided on the inside. So the coefficient of v to the third is 1. The coefficient of 9v squared is 9. The coefficient of 7v is 7, and the coefficient of the constant is just negative 56. And remember, again, if I start with 3, I have to go 2, 1, 0 for my exponents. And so if I don't have any, I have to put a placeholder in. All right, and then so over here, we actually do the opposite. Because if you think about when we subtract in that long division, we're doing the opposite. So what we're actually going to do is take the opposite of this value right here, which is negative 7. All right, and so our process is we bring down the first one. And then we distribute, and we do negative 7 times 1, which gives me negative 7. And since I already did the opposite, I don't have to subtract. I just combine. So 9 minus 7 is 2. And then I do negative 7 times 2, which is negative 14. And then 7 minus 14 is negative 7. And then I have negative 7 times negative 7, which is 49. And negative 56 plus 49 is negative 7. This last number is always my remainder. And so I know that I'm going to have minus 7 over v plus 7 on the end. And then I started out with the thirds, so I just filled this in with one less value. So it ends up becoming x squared, and it's positive 2x, minus 7 over v plus 7. So go ahead and identify any questions that you have on synthetic division, and we're going to do the remaining problems. We're going to do both versions so we can check our answers. All right, so for the remaining examples, we're actually going to work through them doing both long and synthetic because you need to be proficient in both skills. So the first thing that I always need to do is set it up. We're going to do long division on the left and synthetic on the right. So I'm going to put my division sign and fill it in. So I start out to the power of 3. So I have the power of 2, the power of 1, and I have to have a power of 0, so there is no constant on there, so I'm going to put a 0, a placeholder. So if I start out with 3, then I have to go 3, 2, 1, 0, and put placeholders in for terms that I don't have. And then on the outside, I have k minus 2. All right, so we're going to start out. How do I make k look like k to the third? What can I multiply it by? I can multiply it by k squared. So then I'm going to distribute k squared to the binomial. So it's going to become k to the third minus 2k squared, because that is what k times k squared is, and negative 2 times k squared is. All right, then I do the opposite, and I combine like terms. So k to the third minus k to the third cancels, which is what we wanted, and negative 11k squared plus 2k squared is negative 9k squared, and then we bring down the 13k, and we start all over. All right, how do I make k look like negative 9k squared? Well, I'm going to multiply it by negative 9k, and then I'm going to distribute, and so negative 9k times k is negative 9k squared, and negative 9k times negative 2 is a positive 18k. I do the opposite and combine, so these will cancel, and then 13 minus 18 is negative 5k, and I bring down the plus 0. And I repeat one more time. So how do I make k look like negative 5k? Well, I just multiply it by negative 5. And I distribute, so negative 5 times k is negative 5k, and negative 5 times negative 2 is a positive 10. I do the opposite and combine. And so my remainder is negative 10, so it's going to be minus 10 over what I'm dividing into it, and that is my answer. And so remember, if I have a remainder at the end, that means this is not a factor, because a factor means it goes in evenly to what is being divided into. So if this had ended up being 0 as my remainder, then k minus 2 would be a factor. All right, we're going to go through the same problem, but we're going to use synthetic division this time. So we're going to draw our upside down division sign, and then we use our coefficients. So the coefficient with k to the third is 1, and then k to the second is negative 11, k to the first is 13, and again we still need that placeholder. There are no constants. And then just like over here we did the opposite in blue, we're going to do the same thing, only we're going to take the opposite right at the beginning. So instead of doing minus 2, we're going to do 2. And now we just bring down our 1. 2 times 1 is 2. Combine, negative 11 plus 2 is negative 9. And remember, we're just combining, we're not subtracting because we already did the opposite. And then 2 times negative 9 is negative 18. Combine, I get negative 5. And then 2 times negative 5 is negative 10. Combine, I get negative 10. And remember, that's always my remainder. And so I started out with k to the third. So this is going to be k to the second, k to the first, k to the 0. And if you notice, I end up with the same answer. So k squared minus 9k minus 5 minus 10 over k minus 2. And that is my division problem. All right, I'd like you to pause the video, and I want you to try as far as you can long division on the left and synthetic on the right. So regardless of which way you did it, you end up with the answer 10x squared plus 8x plus 4. So go ahead and look over my work. If you didn't get that answer, identify where your mistakes were, and if you don't understand, make sure you write any questions that you have about any numbers that I got or how I thought through that process. Also in this case, because my remainder was 0, x plus 4 is a factor of 10x squared plus 8x plus 4. So it goes evenly into it because there is no remainder at the end. All right, so go ahead and pause the video, and I'd like you to try example 4 on your own, doing both long division and synthetic division. All right, so your final answer on this one should be 9r squared plus r minus 1, and then minus the remainder of 3 over r plus 10. So again, if you didn't get that, look over my work and identify your mistakes and write any questions that you have. And so in this case, because I had a remainder, I cannot say that r plus 10 is a factor of this polynomial. All right, go ahead and pause the video and try example 5 on your own. All right, so for this one, hopefully you got 7a squared minus 7a minus 3, and then you have a remainder of 1, so plus 1 over a minus 6. Look over my work, identify where you made any mistakes if you did, and any questions that you have. All right, so we've done 5 full examples. So we will do more work with this later, but I just want to make sure that you get a basic understanding. So I want you to think about what are 3 errors that you think students tend to make when they divide polynomials, either using synthetic or long division. So think about some of the mistakes that you may have made. What questions do you have? Is there anything that you're not understanding or specifically that you want me to address in the lesson tomorrow? And what do you need to remember about dividing polynomials? So what are your be sure to statements? What are the most important things? Maybe they're steps, maybe they're mistakes that you were making, so things that you need to remember. All right, and let's go ahead and write a summary of this process. So what is synthetic division? What is long division? And what does that mean?